Welcome to the ASL Translator team, where we aim to do real-time image-to-speech classification of American Sign Language. So who are we? My name is Ryan. I'm a second-year computer science master's student focused on bioinformatics and natural language processing.
I'm Connor Kaczynski, a fourth-year ECE computer engineer, and I'm going to go into the master's program next year.
Hello, my name is Sarkis Bozikian. I'm fourth-year computer engineering student, and I am interested in machine learning, robotics, and hardware software.
So the motivation for this project came from filling a need. In particular, Sarkis was in a course where the professor was deaf, and we kind of noticed that no really current broadcasting tools have support for ASL, and it definitely exists. So where they needed to use an actual translator in the course, we saw an opportunity to use computer vision and machine learning to translate ASL in real time without making the professor's life substantially more difficult. In particular, doing this through existing software like Zoom to apply things like closed captioning and text-to-speech to live video with minimal delay. And as a potential use case, you may have seen some of these cameras in lecture halls or in meeting rooms. They come with tracking modules that allow them to follow a certain person, and they often have onboard or remote computing capabilities. So adding a live translation feature to these cameras would be relatively trivial and make the instructor's life substantially easier as a result.
We want to be able to, our goal is to be able to have an MVP, which is a minimum viable product, which is able to translate a proof of concept of the ability to translate raw images of ASL signs. We're going to do this by being able to translate 3 letters, the images A, B, and C, as you can see on the left. Then we want, and for our final product, we want to do video translation, which is for the full ASL alphabet in real time, as you can see on the right here. Then for our stretch goals, we want to be able to fulfill our need, we mentioned before, is we need a way to take the translated letters and translate it into a way for the person using the podcast that can interpret those signs. So we have closed captioning and text-to-speech. And another need we have is a way to distribute this ASL onto a server.
So going into the methods really quickly, we started with multiplex training data. Our initial data set was substantially smaller, and it took a while to find this one, but we ended up finding one based off of a Kaggle competition. We then used 2 computer vision frameworks, namely CVZone and MediaPipe, which are based off of OpenCV as low-code alternatives that make generating a trained classifier substantially easier. We can then take that classifier alongside live video or images to make, in the case of live video, live predictions of signs. And an interesting pre-processing step to note is wireframing. You can see on that little graphic up above where a hand is reduced to about 20 points, namely fingers and a couple points on the palm, which is a dimensionality reduction technique to improve computation at a cost to accuracy.
For our qualitative results, we were actually able to surpass our MVP, which we were able to do real-time video instead of just images for 3 letters A, B, and C. And then for our final product on the right, we were able to do a full video translation of the full ASL alphabet in real time.
So our quantitative results, we use there are different kinds of training machines. One of them is a teachable machine, but that was a failure to do 87,000 images. And then we use in-home training using GPU, and then this is the result of validation of accuracy and training accuracy. And then as we see that both of them, they were close enough, so we didn't have any overfitting issues.
And then finally, for our stretch goals, we were able to show a proof of concept for the closed captioning and text-to-speech, but we didn't get to our other stretch goal due to time constraints.
With that, I'd like to thank you for watching and listening, and we appreciate it. Hope this helps. Thank you.
Thank you.